I want to talk today about graphs of exponential functions. And no discussion of exponential functions is complete without first giving an overview of just some of the places that they are used. So what I have here is a bunch of pictures of a variety of places that exponential functions are used. For starters, they're used for graphing or modeling the growth of money in an account or the decline of money in an account. They're used for modeling population growth or decline for animals, say butterflies or endangered species like this leopard. They can be used for modeling the absorption of a medication into a patient's bloodstream, or using carbon-14 dating with exponential functions can be used to date artifacts. And something that's kind of current at the moment, they can be used to model the spread of a virus. So here is the definition of what an exponential function is. An exponential function is a function that looks like this. F of x is equal to a to the x, where a is a constant. A has got to be positive, so we won't have any negative bases under our exponent. But a is not equal to the number 1. That'd be a rather boring exponential function, 1 to the x. So those are the criteria for something being an exponential function. What we want to do in this section is we want to graph these exponential functions. Before we get into graphing them, I want to remind you of a couple of rules for exponents that you might find helpful as we go through. For starters, we are going to use this a lot. Anything to the 0 power is defined to be 1. Another rule for exponents I want you to remember, anything raised to an exponent and then raised to another exponent, we multiply the exponents together. So a to the n to the m is a to the n times m. And then, although there are more rules for exponents that I would expect you to know for this video, the last one is really important, is remember a negative exponent means 1 over. So a to the negative n means 1 over a to the n. Okay, so let's do a first graph for exponential functions. So for our first graph, let's graph f of x equals 3 to the x power. And since I don't know anything about this graph, I'm going to go back to my most basic way of graphing, which is just making an xy chart. So I'll have x and then y's. And again, since I don't know much about this graph, I'm going to kind of pick a lot of x's. So I'm going to start with x equals 4. So when x equals 4, I have 3 to the 4th power. And using my calculator, or if I know that, that is 81. Wow, that's big. Okay, let me get a few more. How about x equals 2? 3 to the 2 power. That's not so bad. That's 9. So I have the ordered pairs 4, 81, and 2, 9. I'm going to plot. X equals 1. That's nice and easy. 3 to the 1 is 3. So 1, 3. X equals 0. 3 to the 0. Oh, remember, that's 1. So I have the ordered pair 0, 1. Now, although this gives me a good approximation of my graph, it's only part of the picture. So if I take a moment to plot these points, I have x is 0, y is 1. X is 1, y is 3. X is 2, ooh, y is 4, 5, 6, 7, 8, 9. Ooh, we're getting close to the top of my scale. X is 4 is going to be way up here. Oh, not even there. Further off my graph. So I have a rather steep curve here. Let's try that again. Going up to the right. That's about as good as my curve is going to get. I need to see what's happening over here. So I'm going to pick some negative x values. So I'm going to extend my graph down here. And let's start with -1. 3 to the -1. Now remember, negative exponents on a 3 to the -1 is 1 over 3, so 1/3. So I have x is -1 and y is 1/3. X is -1, y is 1/3. Okay, how about x is -2? 3 to the -2, so that's 1 over 3 squared. Oh, that's 1/9. So I have x is -2 and y is 1/9. Well, that's going to be difficult to plot. That's really close to my y-axis. Now there's no way I'm going to get as accurate as I need to be, but just for fun, let's plug in x to the -10. So I have 3 to the -10th, which I know is 1 over 3 to the 10th. I'm curious what that is using my calculator. So my calculator says that's 0.0001693588087. What I want you to notice about that is this. When x is a really big negative number, this y value is still positive. Now I don't have the accuracy to plot 0.0000169 here at -10, but what I do notice is this value is just a little bit above the x-axis. So if I were to graph the rest of this, what I have here is an asymptote along the x-axis. So I have an asymptote at y equals 0, or in other words, the x-axis. And remember, an asymptote is a line that my curve gets close to, but doesn't actually necessarily cross. There are a couple other things I want you to notice about this graph. One thing I want you to notice is its domain. Remember, domain is all the possible x values. The domain here is all real numbers. X can be anything. It can certainly be any positive number. If x is 40 instead of 4, this just will give us a bigger y value, 3 to the 40 power. And x can be any negative value. X to the -100 would just give us a really small decimal that's just a little bit positive. X can certainly be 0, as we did. 3 to the 0 is 1. And x can even, with the help of a calculator, be a decimal or a fraction. 3 to the 1.2 is 3.7319, so about 3.74. So x can be literally anything at all. The next thing I want you to notice is the range. So in this particular graph for just 3 to the x, the range has a low value, a boundary down here of y equals 0, but it doesn't actually touch y equals 0, so I have to put parenthesis at 0, and the y's go all the way up, so 0 to infinity. I always say to my classes that this exponential graph is a bit like half of a skateboard ramp shape to it. So if you know that it has that shape of a skateboard ramp, half of a skateboard ramp, and that there's an asymptote, in this case at y equals 0, you can get a pretty good picture, maybe without so much arithmetic. So let's do some more problems, but maybe with fewer x values than this. Let's graph for the next example, g of x equals 2 to the x plus 5. So instead of picking all of those values I did for x's last time, I'm going to still pick x values, but I'm only going to pick 3 of them. So I generally pick x is 2, x is 0, and x is -2. Okay, here's what we're going to get. When we plug in x is 2, we have y is 2 to the 2 plus 5. So 4 plus 5 is 9. So we have x is 2 and y is 1, 2, 3, 4, 5, 6, 7, 8, 9. When x is 0, y is 2 to the 0 plus 5, which is 1 plus 5, we get 6. So 1, 2, 3, 4, 5, 6. And when x is negative 2, y is 2 to the negative 2 plus 5. Now remember, 2 to the negative 2 is 1 over 2 squared, which is 1/4. And you can use your calculator if you want to get 5.25, or you can just write this as 5 1/4. Let's see, x is negative 2, 1, 2, 3, 4, 5. Here's 5, and just a hair above that is 5 1/4. And what I'm looking for here when I'm doing these points, 2, 0, and negative 2, is two things. I'm looking for, do I see that skateboard ramp shape? And sure enough, I see this graph going up to the right. And secondly, can I identify where that asymptote is? So there does seem to be some flattening out right in here. And if you look carefully, maybe you pick another value like x equals, I don't know, negative 4. 2 to the negative 4 plus 5 is 1 over 2 to the 4th plus 5, which is 1/16. So we've got 5 and 1/16, which is just a little bit bigger than 5. So again, at negative 4, I have something just a little bit bigger than 5. I'm feeling like that asymptote is right at that horizontal line, y equals 5. It is not a coincidence, by the way, that 5 was the number added to the outside of our function. Remember in the problem that we did previously when we graphed 3 to the x, there was a plus 0, and our asymptote was at y equals 0. So if you're looking for a shortcut to getting the asymptote, it's always the number that's added to the outside of the graph, of the function. Most instructors, myself included, require a statement of the asymptote, or at the very least, the line plotted in a dashed format, so we can see where that is. Okay, and that's a pretty good picture of what 2 to the x plus 5 looks like. So let's do a couple more examples, and let's do them even faster than this. Okay, for the next example, let's graph f of x equals 1/4 to the x power minus 1. So now remember, the a, the base underneath the x exponent, can be a fraction. It just has to be positive, and it can't be 1. So this will work. I can tell by looking here that the asymptote is at negative 1. So I think I'm going to go ahead and draw that in there. Again, I'm going to pick 2, 0, and negative 2 for the x's. I find that 2, 0, negative 2 gives me a nice curved shape to my graph, no matter how it looks. So I get that skateboard ramp shape to it. And I'm picking a wide enough variety of numbers, both positive and negative and 0, that I get a good general idea for the graph. So let's start plugging these in. So an x is 2. Y is 1/4 to the 2 minus 1. Ooh, 1/16 minus 1. So you can use your calculator, or you can use fractions and common denominators, but you should get negative 15/16. So that's a negative number, but it's really close to the number 1. So when x is 2, y is negative 15/16. Okay, Okay, when x is 0, y is 1/4 to the 0 minus 1, which is 1 minus 1, which is 0. Oh, okay. Goes through 0, 0. And then finally, when x is -2, 1/4 to the -2. Now remember, when you have a fraction, say a over b, raised to a negative exponent, that negative exponent is directions to make everything in the denominator in the numerator and everything in the numerator in the denominator. So a shortcut is you can take a over b to the negative n and make it b over a to the positive n. For our problem, then, we can take 1 over 4 to the -2 and make it 4 over 1 to the positive 2, and then subtract 1, which is 16 minus 1, which is 15. So we have x is -2, and y is way up here at 15. Now I have a great picture of what my graph does. This curves up to the left. Let's try to graph this. And goes down to the right. Well, that's a pretty rough sketch of what I have. Let's try another one. Let's graph one of the most important functions, e to the x. Just in the same way that the number pi is a constant, an irrational constant that's really close to 3.141592. E is a similar number. E is an irrational number, really close to 3 actually, 2.718281828, and so on. It doesn't repeat, by the way, forever. So when we go to graph this one, we're going to need to get out our calculators. So I'm still going to plug in x equals 2, and I'll add 1, 0, and -2. So let's see, when x equals 2, I have e to the 2. So when I plug in, you should familiarize yourself with how to plug in e to the 2 on your calculator. So when I plug in e to the 2, I get 7.389 about. So x equals 2, 7.3, 1, 2, 3, 4, 5, 6, 7, 8. So 7.3 or 7.4 is about here. So we'll put a big fat dot. When x equals 1, e to the 1, oh, I know that. We just calculated that. That's 2.71828. So let's see, x equals 1 is 1, 2, 3. So about here is e. X equals 0. Hey, that one's easy. Anything to the 0 power is 1. I'm starting to see this take shape now. E to the -2 wouldn't be a bad thing to know how to plug into your own calculator. Everybody's is a little different. You should get 0.1353352. So about 0.14. 1, 2. But what I can notice here, taking shape with this graph, is the graph is going up to the right, like the first few, and since there's a no number added to the outside, it does seem that that asymptote is again along the x-axis at y equals 0. So our asymptote is at y equals 0. Okay, let's do one more graph. Okay, for our final example, let's do another graph with e in it, and let's graph f of x equals e to the -x plus 1 plus 4. So first thing, I always like to start off graphing the asymptote when I see it, and this asymptote is at y equals 4. So let's 1, 2, 3, 4. Let's graph that. And I'm going to still plug in x equals 2, 0, and negative 2. So I'm going to need my calculator because of the e. E to the negative 2 plus 1 plus 4 is e to the negative 1 plus 4. And I'm just going to approximate this to 1 decimal place. So approximating that to 1 decimal place, I've got 4.4. Okay, so when x equals 2, y is equal to 4.4. Okay, when x equals 0, I have y equals e to the negative 0 plus 1 plus 4, which is just e plus 4. And using my calculator, I'm going to get 2.7. I'm sorry. No, I'm going to get 6.7. So when x equals 0, there's 5, 6, 7, so about in here. And then finally, when x equals negative 2, y equals e to the negative 2 plus 1 plus 4 is e to the 3 plus 4. And plugging that into my calculator, e to the 3 plus 4 gives me, 24.1 if I round. So at negative 2, I'm way off the charts, way up here at 24. But I've achieved what I wanted. I have a good idea of what my graph looks like. Definitely curves up to the left and then goes down to the right, the asymptote at 4.